Earth science time. This is the third Earth science. It may be the fourth. Fourth or fifth, maybe, Earth science time. We're going to title this Surface Processes. Surface Processes. And then there's going to be a subtitle. Ooh, there's not always a subtitle. Surface Processes. And the subtitle here is going to be Weathering, Erosion, and Soil. I was specifically asked not to ask questions by some of our classmates. Well, here's a question for you, Camden. Why do you think I have chosen to subtitle this? This is a good question because it starts with, why do you think I have chosen? So there's some leeway in this.
Okay, well, I think you put the subtitle because it's not going to be the only thing we're talking about today, and so we have a basis of what everything we'll be learning in this section.
That is almost right, except it's not, we are going to only be learning this today, but it's not the only thing about surface processes. Yeah. So this is all we're learning today, but there's more to surface processes than just these things. Although these are probably, these two certainly are the biggest ones, and then we're going to talk about soil kind of as a side dish. Here's the prime rib. You guys, you a vegan. This is the broccoli pate, and then this is the vegan side dish. Rice.
Rice.
Okay. So this is a little side dish. Side dish, look up side dish on Urban Dictionary too. Don't do that. Don't really do that. Not a suggestion, not a sponsor. Don't do this. I think what it is like when you got a significant other and then you have a side oh yeah. Anyway, we don't have to talk about that at all. I'm going to cut that. Okay, weathering, erosion, and soil is what we're talking about. Golly, okay, let's get started. So we're going to start with weathering and erosion. And you've heard these two things together, or grouped together. You probably learned at least a little bit about this in elementary school. Is that right? You're aware of the existence of weathering and erosion. But here's the key bit that people don't always understand about weathering and erosion is they are completely different processes. They go hand in hand. Peanut butter and jelly, right? They go hand in hand, but they're completely different things. So weathering and erosion. We're going to start with weathering. Weathering is the breakdown of earth material. What's another thing I could put that would be slightly less true and slightly less all-encompassing for earth material? Weathering is breakdown of earth material into, and I'm going to leave a spot there because we're going to talk more about that. What could I say to be, that would be earth material? When I say earth material, what do I primarily probably mean? Rock, yeah, breakdown of rock. In fact, I used to, and it still could be defined as breakdown of rock. But we're going to be more general. Breakdown of earth material into, well, what is it being broken down into? So for instance, if I had a rock and it's breaking down, yep, sediment, into sediment. And then erosion, how is that different? Well, weathering we said is the breakdown. Yeah, there you go, good. Movement of sediment. And then there's another process that we need to talk about called deposition. What might that be? Mm-hmm. Deposition is when, basically it's just the stoppage of erosion. When erosion ceases and sediments are deposited. We sometimes even use the verb phrase laid down. Sediments are laid down. And that's it, right? No, there's other processes too. Do these fit into the rock cycle? We had talked about these before. Do these fit in the rock cycle? Yeah, they're part of the rock cycle. It's how sediment is produced. And then how does this sediment, after it's been deposited, become sedimentary rock sometimes?
It can become sedimentary rock because the sediments of weathering is what forms the sedimentary rocks. Like instead of how the metamorphic rocks are formed by heat and pressure.
Yes.
Those are made out of pieces of sediment and pressure.
Or any kind of rock. It can also be just it's already a rock. But yeah. And then in sedimentary rocks, these sediments, when they have, not necessarily heat, but when they have pressure applied to them, that becomes sedimentary rock. It doesn't always even have to be pressure, but when they're what we call lithified, when they become rock. Why would we call this whole thing, we've kind of worked backwards, why would we call this whole thing surface processes? It has to do with, go on.
Most
Right.
Earth rather than under.
Exactly. These events happen on Earth's surface, as opposed to, as you say, as opposed to inside the Earth. And we have to make that. We don't normally make that specification. Like, I don't say, this is a used car dealership on the surface. You know, it's just that in geology we do make this as specification because
There's rocks underground.
exactly, because there's geology underground. There's used car dealerships underground, or at least most of them aren't. None of the ones I'm aware of are. But so we specify surface processes as opposed to interior processes, which is what we talked about in the igneous chapter. Your book has excellent, in fact, I think superb examples of each of these occurring, and you can look into those some more. But a thing that we really need to talk about with erosion is that in general, and we're going to write this down, in general, erosional media, we're going to underline that, with more energy can move, I'm going to leave a blank, sediment. We're going to talk about this together. In general, erosional media, first let's talk about that. What does this word media mean?
Would it be like outlets of information?
Okay, so in the news media is what you're thinking of, or artistic media are those things that the news or the art is relayed. It's presented, as you say. It's in the same way. Erosional media just means different types of erosion. There's different ways erosion can be conveyed effectively. And in singular, so media is plural, singular is medium. You see this a lot more when we talk about those three things. Erosional media, artistic media, and news media. We almost never hear of a news medium, but like ABC News is a news medium. It's a way through which we get news. We do hear about the medium in art. This painting's medium is oil on canvas. That means it was made using oil on canvas. And we do also talk about erosional. An erosional medium is one way that erosion can occur. Let's list some erosional media. Can you think of any? What are some ways that erosion can occur on Earth's surface?
Wind and water.
Wind, okay. And I'm going to make a column. This is what we would, like normal folks speak, and this is going to be a fancy speak. Can you see these on the video? Kind of. We call that aeolian erosion in fancy speak. A-E-O-L-I-A-N, aeolian. It's kind of related. I don't know if it's actually etymologically related to the word aero, like an aeroplane, but it looks like it, so that's how I remember it. Wind, which is what we sometimes call aeolian, and you said water, but there's lots of different kinds of water. What's one way that water can erode things?
Like
Say it.
a river.
River. And we call that fluvial. What else? Let's stick with water for a while. What other ways can water erode? Or what other media can water cause the movement of sediment?
Could natural disasters be like something like that?
Yeah, and we'll move that. I mean, natural disasters is kind of broad, but we will move some types of natural disaster further down. But what are some other ways that water can move sediment? Like, really, you have one kind of water here. Basically, what are some other kinds of bodies of water?
Like a stream or
Okay, stream, and we do have words for stream and what we call rill and gully, which are just kind of smaller versions of fluvial. Those are all fluvial erosion, but river / stream / rill, river, stream, rill, gully. Those are just, I put them in a weird order, but really, a rill is kind of like, I can see a rill outside right now. It's just like a place where sediment has formed a chasm because a lot of washout has occurred. That's a rill. And then a gully is if it's quite a bit deeper, like you'd see if you go something, they'd be pretty deep. They wouldn't, but they'd be gullies. And then a riverbed is larger than that, and that's all fluvial erosion, which is kind of running water erosion. What else? What other kinds of, besides those, running water erosion, what other bodies of water can move sediment? You can think of some. What's another maybe bigger, much bigger body of water? The ocean, which is what we call marine erosion. And there's also tidal, and that's different from marine, but we'll leave that off the list. What else? There's another kind of body of water that I'm really anxious for you to get up here. Okay, put down here, glacial, which is the fancy name and the regular people name. Okay, I'm going to tell you lake, which is we call lacustrine. Oops, I kind of ran out of room. Lacustrine. And then we also have mass movement, which would be like landslides and stuff. There's more to it than just landslides. Trying to think if there's anything that I'm missing. Okay, be aware that there may be some that I'm missing. But these are some examples of erosional media. And actually, Unit 2, this is Unit 1, Lesson 1. But sorry, this is Unit 7, Lesson 1. And then Lesson 2 is about these specific ones, kind of. Okay, so in general, erosional media, which are the different ways that erosion can occur, with more energy can move what kind of sediment? You found this in the lab, hopefully. More energy. First of all, how could we...
If it's like water, like movement of water, it would be like speed.
Okay, so, yep, so speed, basically. If we're talking about the same literal chemical material, then it's speed. If for instance, all these kinds of water ones, the faster it moves, the more energy it has. But then also, comparing wind and water, water per unit of volume has more mass than air. So therefore, even like for instance, a 30-mile-an-hour wind would have energy as even a 1-mile-an-hour flow of water because water has more mass. So it has to do with both the mass and velocity. And what does that kind of remind you? Do you remember from physical science? Was there any specific kind of energy that contained mass and velocity?
Is it like kinetic?
It is kinetic.
Okay.
Kinetic. In general, erosional media with more kinetic energy can move what kind of sediment? This is the key word here. More energy means what kind of sediment can be moved? That you found? Larger. Exactly right. And then let's remind ourselves of the sizes of sediment. This was from our sedimentary rock video too, but in order of decreasing size, the biggest kind of sediment. There are things like boulders and flagstones and stuff that we're not going to talk about, but what's the largest kind we talked about previously? Do you remember?
It was on like the what kind of rock?
Sedimentary rocks, classic sedimentary rocks.
The largest was clay size?
That's the smallest.
Second, pebble?
Pebble.
Okay.
Then going down, next one down.
Sand.
Then,
Silt.
then,
Clay.
good. Clay, and I'm also going to put dust in there. And there's a distinction between those, but in general, erosional medium with more energy can move larger sediment. And that seems simple, and it is pretty simple, but it generates a lot of interesting things, which is like, for instance, if we have a stream that's moving quite quickly, and then there's an eddy in the stream which causes it to slow down, we would expect to find a certain size sediment in that stream. For instance, if the sediment that's being moved is all pebbles, then we might find pebbles in that eddy current area, a little deposit of pebbles. And the reverse of that, like thinking about that truth and applying it to sedimentary rocks that we find, can tell us a lot about the nature of ancient stream beds, which we wouldn't have known about if we didn't know this pretty simple truth. I'm even going to call this an axiom, which is what we call like a simple truth. Just because it's simple doesn't mean it's not useful. And we can really complicate it by thinking really hard about it lots of times, but an axiom that in general, erosional media with more energy move larger sediment. And then if it loses energy, so that means that there will be more erosion with more energy, and then if it loses energy, what's going to happen? What verb will apply to the sediments? They will be, if the erosional media loses energy, then what will happen? What verb will happen? There will be deposition. Good. Yeah. Okay. Questions about erosion in general? Let me make sure that I covered everything. Well, okay, that was a mistake. I am not trying to cover everything. I still want you to have to read. Now, I especially want you to look at the examples because the examples in here are great, in my opinion. But this is, I would say this is the basics. Do you have questions about the basics of erosional?
No.
Okay. Let's move on then to talk about weathering. Weathering we can break down into two main categories, which are chemical and physical. So let's talk about those now. I'm going to leave where it says weathering up there. Weathering is the breakdown of earth materials to form sediment, and it comes generally in chemical and physical weathering. And this is a pretty, oh, I'm sorry, put on your table, I just erased it, but put on your erosional media table, biologic or biogenic, which means life. Life can erode things, because unlike, a lot of times we try to, in science, it feels like we try to exclude the human factor, but that's not the case in geology or earth science, because really, like if you go to the track and grab up a handful of rock and go put it somewhere else, that's erosion. And geology is really good about accepting that. There are human causes of erosion as well. Not just human, but animal. You know, like if Richard Parker goes in the yard and digs a hole to take a bloody stool in, then that is erosion. It's biogenic erosion, but it's still erosion. Good. God bless him. Okay, chemical versus physical weathering. I don't know that we need that line. That was a useless line to draw. Can you tell, just from your prior knowledge of these from chemistry and physical science, what's probably the main difference between chemical and physical weathering? Probably, it might not be in your notes, but like, just what's the difference between a chemical and a physical change?
Chemical change is based on a reaction.
Yeah, chemical, so there must be a chemical reaction. Chemical reaction. The substances must change. And we're going to have some room for some examples. And then in a physical change or physical weathering, what probably happens then? Is there a chemical reaction?
No.
Probably not. Or no, there can't be, otherwise it would be there. And then do the substances change? Like, is it the same stuff before and after? Yeah, it's the same stuff. It's just what has changed about it then.
It's appearance?
Okay, appearance. What else?
Um,
Usually specific, because we're talking about weathering, which is breakdown. What else has changed about it generally?
the mass of it, like how much
It's probably, in total it's the same mass, but but you're right, the mass of the different outcomes, they all add up to the same, but each individual thing would have a smaller mass. Okay, so mass. And what else can change about it? I'm looking for another specific thing.
I know, I don't know what it is.
Size is what I was looking for, but just like volume, the amount of room it takes up. Change. And probably also shape, but not the substances. It's still, so for instance, if we have iron pyrite, which is FeS, it's iron sulfide as a crystal, and if it undergoes physical change, what would be an example of physical change of iron pyrite? It doesn't matter that it's iron pyrite, but what would be an example of physical change? Like, what could I do to it? What could I do to cause biological weathering to the iron pyrite? It's physical.
Pick it up and move it.
That would be erosion. But how could I break it down physically?
If you, that would be a chemical reaction.
We have these crystals. Yeah, if I break it, yeah. Like we had those crystals that we made in the lab. I physically weathered a lot of them yesterday because as I was touching them, they broke. So just literal breaking. There are more examples than just the breakage, including frost wedging, which you need to look up and read about, exfoliation, which you need to look up and read about. To some extent, dissolution, it depends. I'm going to put a little approximate sign next to it. Dissolution means that it has been dissolved. That can be physical weathering if it's just, like for instance, if it's just sodium chloride and it dissolves in water, and the sodium chloride gets taken apart into sodium and chlorine, and then the water evaporates and the sodium chloride go back together, that would count as physical weathering, in my mind at least. But you could also count it as this, like the acid dissolving limestone. That would definitely be chemical weathering. So I'm going to put dissolution over here too. What's the verb of dissolution, just so we're all on the same page? Like if dissolution has occurred to something, it has been what?
Broken down.
Yeah, I would say dissolved. That's what I was looking for, is dissolved. It's like when I say this is being dissolved, it means the dissolution has occurred. Another one of these is oxidation, like what we'd call rusting sometimes. Burning, certainly, if it can burn. Water can react with it. And then, importantly, when we're talking about weathering and erosion both, a thing called surface area becomes really important. Big surface area means fast rate of weathering. The classic example, and we did this with the old curriculum for science, we would take a sugar cube and then that exact mass also of granulated sugar and just see which one dissolved faster. And obviously the granulated sugar dissolves faster because it has a greater surface area. Okay, and then lastly we're going to briefly talk about soil. And the main thing I want to do for soil, do you have questions about any of the weathering before we move on?
Just break it down.
Okay, I'll wait for a second. Your book also goes into some amount of detail in rippling and cross-bedding and beds in general, which you should read about. That's in there about in the deposition section. And then we'll talk about soil. The main thing I want to talk about with soil is the soil horizon diagram. And there's more to soil than just this, but there's Miss Cooper has a class about soil science or something like that, right? Don't you do soil in one of her classes, or someone does? Anyway, I'm going to kind of mostly leave this alone, not just because of that, but also because your book is pretty scant on it. The horizons of soil, what we call the soil horizons, are in order. They're the O horizon, which is organic, like leaf litter and chomped up organic matter is the O horizon. The A horizon comes next. Then there's the B horizon. Then the C horizon. And then the D is the bedrock. What's bedrock? Yeah, in Minecraft, it's the very, very bottom, isn't it? In geology, I don't remember if I told you this before, but unlike Minecraft, where bedrock is the very lowest layer, bedrock in geology is the highest layer of actual rock. So all these things are above the bedrock, but what are these? Soil. They're soil. The bedrock is the highest layer of actual rock. So like in my yard, there's bedrock. I might have to go down 6 inches below my soil. My soil's not that good, but below that is siltstone, which is bedrock. It's the highest layer of actual rock. But then there's a lot of times there are a lot of things above the bedrock. So the A horizon, your book doesn't say anything about the O horizon. This is from the old book, but I do think it still exists. There's an organic material that's just organic material on the top, like leaf litter and stuff, comprises the O horizon. The A horizon is largely organic still, largely organic. The B horizon is what we call subsoil, which is sediment, and there still is some organic, but and that's fine. And then the C horizon is large sediments and regolith, which is what we call a group of weathered rock. My handwriting is getting much worse. And then the D horizon is the bedrock, as we said before. It's solid rock material. Could be anything. Limestone, siltstone, granite, doesn't matter. Rock, it's the D horizon. Where would the soil be the most nutritive for plants, probably? The O horizon. And then there's also a lot of times, this relates to water. We'll get into groundwater, hydrogeology in a bit, but The A horizon, a lot of times this is super permeable, so the water just fills this up, and then it'll trickle down pretty quickly through the A, and then there will be some, B is sometimes called the leaching zone, where water will leach through, and then the C, generally, certainly the D horizon, but the C horizon, a lot of times will just stop water, or the water table will be here, and this will all be saturated below here. Why bring up water in this? Well, water is obviously a huge important part of the dynamics of soil. Do you have questions about soil, the side dish? Know the side piece, yeah. Know the layers, the soil horizons, and kind of have some general familiarity with what each one contains. And in order to do that, it'll behoove you to look at the diagram and read the little article here with it. But if you don't have any questions, like, comment, subscribe. Bye, comrades.